Special relativity. It's a trick solution to an insoluble problem. Now, before Einstein, physics had a problem. They'd done experiments on the velocity of light and measured it, but they were expecting to find evidence of a stationary medium, which they called the ether. And the experiments found no trace of this medium. So this was an impasse, really. So enter Einstein, and he simply said, we don't need an ether, we can simply consider light to have constant velocity c. He gave it the notation c relative to all reference frames, regardless of the relative motion of those reference frames. So everybody everywhere would measure light to have the same velocity. Okay, so to show exactly what that means, two reference frames, yours and mine. Okay, look in our spaceships out away from any planet or star, no gravity, is floating, so we both consider ourselves stationary. But we have relative motion, so as I look back, I see you moving towards me in that direction with velocity v. You look forward, you see me moving towards you in that direction with velocity v, the same velocity v. Okay, now as we come alongside each other, a torch flashes very briefly and sends a pulse of light along the direction of our relative motion. Okay, so we can both consider that the torch for that split second was motionless in our own reference frame. Okay, so the pulse travels off and for a long way and hits a mirror and is reflected back along its original path. So it gets back to you first and eventually to me. Now, before relativity, the common sense interpretation of this, from my point of view, if I assume that the pulse has velocity c on both its legs, both legs of its journey, out and back, it must have two different velocities for you. Okay? So if I assume velocity c on both legs, therefore for you I would expect the pulse to have velocity c minus v on its outward leg relative to you, c plus v on its return leg relative to you. Now I would expect that if we both measured this journey, the time and distance, that you would confirm that this was the case. Because the pulse is travelling slower than c for longer than it is travelling a velocity greater than c, it will take longer to get back to you than it would if it had velocity c relative to you for the whole journey. So you would have to confirm that situation and the fact that the pulse has in fact had two velocities relative to you. Now, what the equations of special relativity actually do is to modify your measurements. If your clock were to be running slower than mine, and the instruments that you measure distance with were contracted relative to mine, then the pulse would appear to you to have travelled a greater distance in a shorter time than I would measure that journey back to you. So you would then get the correct time and measurement of the journey so that you could confirm that the pulse had velocity c relative to you on both legs. So there is the trick. That's what the equations of the theory, the Lorentz transformations, do. They convert two velocities into one for you by slowing your clock and contracting your distance measuring instruments. In effect, you are being fooled into thinking C is preserved for you. But of course, you can apply the theory as I do. You would see the situation, same situation like this. The pulse would have velocity c on both legs relative to you. There we see the pulse getting back to you and returning to me. So if the pulse has two velocities relative to my reference frame, then it must be my clock must be running slower and my measuring instruments contracted to enable me to get the correct result when the light pulse returns, so that I believe that the pulse had velocity c on both its legs. So we reciprocate the same trick. Okay, now we can show the same situation in a two-dimensional diagrammatic form. Just to rub it in, this is the same situation. Here we have a time axis and a distance axis. So I consider myself motionless, so as time passes, we can say I simply move up this axis. you move through time also this way, but you are moving away from me. So that is your, what we call a world line. The blue line is the world line of the light pulse. You can see it travels away from us both, hits the mirror there, returns first to you and then to me. So if I receive the light pulse back at time 2 big T, then I can assume that it hit the mirror halfway through that total journey at time big T. So everything on that line is time big T for me, so that's what we can call my line, a line of simultaneity. So your clock has a reading on my line of simultaneity for the mirror strike, which we'll call little t. Okay, now by special relativity your clock is running more slowly, so little t is smaller than big T. Now from your point of view, you receive the pulse back here, so we'll call that 2 little t dash. You know it hit the mirror halfway through that total journey, so that would be little t dash. So for you that is a line of simultaneity, so it's different to mine. The reading on my clock on your line of simultaneity for the mirror strike we'll call big T dash, and by special relativity, because my clock's running slower, big T dash is smaller than little t dash. So that all works. Also the diagram preserves the velocity of c on both legs for us, for both of us. If you extract my part of the diagram, you'll see that the pulse covers unit distance in unit time on both legs. And if we extract your part of the diagram, the pulse again covers unit distance in unit time on both legs. Okay, but it's still a trick. Because the inevitable consequence of this obviously is that both our clocks have to be run slow at the same time, which is a nonsensical statement obviously. So I think you'll see I'm not misrepresenting the theory. This is how it works. Because if you enter simple values into the Lorentz transformations, the equations, for say t and the velocity at which you are moving away, you arrive at a value for little t. This then scales this line, your timeline, from which you can just simply measure on that line and get a value for little t dash. If you then enter little t dash and V into the equations, you will indeed get big T dash. So that represents how the theory works. So proponents of the theory have to own this diagram. And as I've said, it works, but it only works because we've invented another dimension. We are showing a sequence of events which happens in one dimension, in two dimensions. And what is the justification for creating a dimension? Where is this dimension? And as I said, it simply leads to a nonsensical conclusion. To describe this situation, I have to say relativity is working for me. His clock is running slower than mine. But at this minute, he's saying exactly the same thing. He's saying that it's my clock that's running slower than his. And he's got to be right. We've both got to be right. Well, clearly we can't be both right. It's as simple as that. It's a mathematical trick. It's an abuse of mathematics, really. And why is it that physicists, proponents of the theory, will defend this? I mean, have they actually got a lack of some kind of critical faculty? That would, that would lead them to reject it. What I'm saying is, have they some deficiency? Are their brains wired up wrongly or something? Well, that's hard to believe. Another possible factor is it's just the strangeness, the weirdness of the theory. Maybe it has such a powerful aesthetic, emotional appeal to them that they're blinded to the just the common sense reaction that would lead them just to reject it. Maybe they think common sense is superseded, that they and they alone have more imagination. They're more open-minded and able to accept the counterintuitive. So ever since I've came to understand all this, then I've been very sceptical of a lot of modern physics, cosmology, things like quantum, and I've got some thoughts on various other subjects, and I hope to be posting some more soon.